Ever wondered how doctors decide which medicine to give you when you're sick? It's not magic or guesswork. It involves a lot of data and a method known as K-means. Today, we're going to break down this concept in a way that everyone can understand. Imagine a room full of people, each of whom is feeling unwell with different symptoms. Some have a cough, others a high temperature, and still others a runny nose. Now, the doctor has to figure out which group of symptoms corresponds to which illness, and so which medicine to prescribe. This is where K-means comes into play. It's a type of algorithm or a set of rules that computers follow to solve problems. In our case, the problem is grouping these people based on their symptoms. The K in K-means stands for the number of groups we want to make. The first step in the process is to randomly pick K number of points. Think of these as the initial guesses for the centers of our groups. For example, if we're trying to group people into 3 illnesses, say cold, flu, and allergies, we would pick 3 points. Output. Next, each person in the room is assigned to the nearest of these points based on their symptoms. This creates our initial groups. But we're not done yet. Now we need to make our groups better. We do this by finding a new center for each group based on the symptoms of the people in that group. Then, we reassign each person to the nearest new center. This process repeats until the centers don't change anymore. The result? We now have groups of people who are likely to have the same illness because they share similar symptoms. And this helps our doctor decide which medicine to prescribe for each group. To sum up, K-means is a method that helps us group similar things together, like grouping people with similar symptoms to help decide on a treatment plan. It starts by randomly picking K number of points, assigns each item to the nearest point to create initial groups, and then improves these groups by recalculating the centers and reassigning items. It seems like if we're referring to the concept of individualization in the context of clustering algorithms. Specifically, K-means. If we individualize each person in a data set, the within-cluster variation WCC, or variation in symptoms, becomes 0, suggesting a perfect fit for each individual within their own cluster. This could imply that each person is treated as a unique cluster, eliminating the variation within those clusters. However, achieving 0 within cluster variation may not always be desirable, as it might lead to overfitting or loss of generalization. Individualization could potentially result in a model that is too tailored to the idiosyncrasies of each data point, making it less applicable to new, unseen data. It's essential to strike a balance between fitting the model to the individual characteristics and maintaining generalizability. The choice of clustering approach and the level of individualization depends on the specific goals and characteristics of the data set. This repeats until the centers don't change anymore.